So hello guys, I'm your Mark Ponce from Xavier University. I'm here to tackle about the statement level control structure. So what is statement level control structures? So a control structure is a control statement and statements whose execution it controls. So that was the statement level control structure is. So in this chapter we will discuss about the flow of controls among the statements, which is the sequence statements rather, and the selection statements and the iterative statements. So next one is flow of control. So what is flow of control? So flow of control through any given function is implemented with the basic types of control, which is the sequence, selection, and repetition or iteration. So these three majors are the basic levels of the statement level control structure. So a control structure is like a block of programming that analyzes variable and chooses a direction in which to go based on the given parameters. In the term flow control, details of the direction or the program takes, so which the program controls the flow. So the next one is the goto control structure. So what is goto? So goto statement is used for transferring the control of a program to a given level. The syntax of goto statement looks like a goto level underscore name and semicolon. So the program structure goto statements are almost never used in any development, as they are complex and makes your program much less readable and more error prone. So in the program we have any number of goto level and statements. The goto statement is followed by a level name. Whenever goto statement is encountered, the control of the program jumps to the level of specified goto statement. So next one, we will have the first major basic structures, statements of the level control. So first is the sequence. So a sequence as a control structure uses compound statements or blocks to specify sequential flow. So a compound statement, a block of code, is used to specify a sequential flow. So in this example here, the statement 1, statement 2, and statement 3. So the sequence have a do one action and another, then another, etc. So in this example we have a step-by-step process of your program. So the sequence control structure refers to a line-by-line execution, by which statements are executed sequentially in the same order in which they appeared in the program. They might, for example, carry out the series of read or write operations, arithmetic operations, or the assignment to variable. So this is an often overlooked controls because it is so pervasive. So a standard part of any imperative program is a sequence of statements to be executed in the sequential order. Functional programming languages get sequential execution from left to right, or order of evaluating the arguments to the function. So logical programming languages also have often left to right evaluation order. So the semicolon here and statement 1, 2, and 3 started out as the statement separator, but it turns out to be cleaner syntax to make a statement terminator, as it the most current language. A compound statement is a sequence of statements treated synthetically as one statement. The statements in the compound statement are usually surrounded by braces. So the braces here before the statement 1 and after the statement 3. So but some language used to begin, end, or bracketing keywords. So a block of compound statement in which variable may be declared with scope limited to that compound statement. So next one is the selection statement. So selection statement, the selection control structure allows one of the sets of the statement to be executed if a condition is true, and another set of action to be executed if a condition is false. A structure is also called an if then else structure. Is flowchart as follows. So first, the if else and else if. So if you want a program to do something if a condition is true, but do nothing if the condition is false, then you should have a if and structure. So else if you want the program to do something if a condition is true and do something different if it's false, then you should use an else structure. So if you want to test multiple conditions, then you can include itself structure within an end of if else structure. So for this example, the structure about if and. So the first one. So for example, we wanted to know. So if and structure if and selection of the selection statement. So if and selection structure are used when only one Boolean condition is necessary, and if and structure is a process will only be performed in the Boolean condition is true. So for example, we wanted to know the number of days from the data set where the daily high temperature is above 80 degrees. A program could use a if and statement. So when the day is above 80 degrees or 80 temperature, the Boolean condition is true, and the variable num above 80 increased by 1. So the next example is the if else. So if else selection structure are used when only one Boolean condition is necessary, and in if else structure rather, a specific action will be performed if the Boolean condition is true and another action in the condition is false. So for example, we wanted to know the number of days from the data set where the daily high temperature was above 80 degrees. A programmer could use an if else statement. So when day is above 80, the Boolean condition is true. The variable above 80, the variable num above 80 increased by 1. However, when days is not above 80, the Boolean condition is false. The variable of num below 80 here increases by 1. In this case, num below 80 is actually the number of the days less than or equal to 80. So that was the else if structure is. So the last one here is the else if. So else if structure are a way to combine multiple Boolean conditions into a single structure. So, to the single selection structure. So in this example here, let's say that instead of a temperature above and below 80 degrees, we want to know the numbers of days when temperature were above 80, below 50, and in between. In this case, a programmer would use an if-else structure. Else-if structure. When the day is above 80, the Boolean if condition is true. Then the variable num above 80 increases by 1. If the day is above 80, then the Boolean condition is false, and the selection structure moves to the else if condition. Now, if day is below 50, the else if Boolean condition is true. The variable num below 50 increases by 1, and if the else if Boolean condition is false, then the condition structure moves to the else condition, and the variable num BTW, or by the way 50 and num between 50 and 80, so increases by 1. So the next one, the last major types of the statement level control structures is the iteration or iteration. So The iteration structure executes a sequence of statements repeatedly as long as condition holds true. The sequence structure executes a sequence of statements in order which they occur. So, in iteration control structure, a statement or block is executed until the program reaches a certain state, or operations rather have been applied to to every element of a collection. So this is usually expresses with keywords such as while, repeat, for, or do, or until. So the basic attributes of an iteration control structure is to be able to repeat some lines of code. So the visual display of the iteration creates a circular loop pattern when flowchart. Thus, the word loop is associated with the iteration control structure. So, iteration control structures can be accomplished with the test of before loops and test after loops and counting loops. A question using Boolean concept usually controls how often the loop will be executed. So that's all about the statement level control structure. So my groupmates will have a deep explanation or deep examples about the three major concepts of the statement level control structure. So I hope you will understand well what I am talking about. Then I hope it will help in your education. So that's all. Thank you.
Hi everyone, I'll be teaching you one of the major control structures called iteration or loops. So this is the overview of our topic. So in loop control statements, we have for loop, while loop, and do while loop. While loops and for loops are considered pre-test loops, and do while is considered post-test loops. So before we start tackling this type of loops, we will start by asking, what are loops or iterations? Loops or iterations are repetitive executions of certain statements. Loops allow the block of statements to be executed repeatedly without actually writing them down numerous times. So it will continue to execute the statements until the condition of the loop is met. And when a certain condition is met, the loop will stop and will continue on to the next statement below. Now we know what loops or iterations are. Let's proceed to the pretest loop. So in pretest, the condition is verified each time before entering the body of the loop. The test condition will start at the beginning and then will run the statement. And when the test condition is satisfied, then it will go out of the loop. In post-test, the test of the loop condition occurs after the body of the loop has been carried out one time. It means so the statements of the loop are always executed at least once. Let's now go into counter control loops. Counter control loops is often called definitive repetition because the number of repetitions is known before the loop begins executing. The expression can be whole statements or even statement sequences with the statement separated by commas. A counting iterative statement has a loop initial variable and a means of specifying the initial, terminal, and step-side values. Also, for loop is a counter control loop. For loops, here is the syntax of for loops. It consists of init, condition, and increment. This tree expression is separated by semicolon. The init step is executed first and only once. This step allows you to declare and initialize any loop control variables. You are not required to put a statement here, as long as a semicolon appears. The condition is evaluated. If it is true, the body of the loop is executed. If it is false, the body of the loop does not execute, and the flow of control jumps to the next statement just after the for loop. After the body of the for loop executes, the flow of control jumps back up to the increment statement. This statement allows you to update any loop control variables. This statement can be left blank as long as a semicolon appears after the condition. So take note, the loop parameter expressions are evaluated only once. So changing variables that are part of them doesn't affect the number of times the loop is executed. Also, the number of times the loop is executed is controlled by the iteration count, not the value of the variable. So assigning to the loop variable inside the loop doesn't affect the number of times the loop is executed. So, logically controlled loops. Repetition control is based on a Boolean expression rather than a counter. So this is what logically controlled loops. The pretest logically controlled loop referred to as while loop, while post-test logically controlled loop is do while loop. You will soon know why. And the only real difference between the do while loop and the while loop is that the do while always causes the loop body to be executed at least once. So while loops. The initialization will start at the beginning of the loop. Then it will run the statement and update the counter variable. So here is the syntax of while loops. Next, do while loops. The expression in a do while statement is evaluated after the body of the loop is executed. Therefore, the body of the loop is always executed at least once. So here is the syntax of do while loops. And I hope that you learned something today.
Well, hi, I'll be showing you what the if-else control structure is. Well, the if-else control structure is probably the most commonly used control structure in any programming language. It allows you to test a condition and act on it depending on whether it's true or false. It allows you to test a condition, so when a condition is true, it will do something. While the condition is false, then it will do something else. But let me show you how it really works in an actual code or actual program. Disclaimer! This video tutorial is about the control structure if-else. Prior knowledge of the basic of Java may be required. This may also serve as a refresher tutorial for programmers. And now we're going to proceed to the video. So first things first, we're going to make the class. We're going to name it if example, because we're going to show if-else examples, okay? And now we're going to make the main method. First, we're going to initialize a certain age limit for a driver's license. In this case, let's make it 18 because that's like the legal age in the Philippines. And now, we're going to use to initialize a scanner. Before that, we're going to import the Java util. We're going to import it all instead of just a scanner, okay? We're gonna use two scanners for the clarity of this video. One can be used, but for the sake of this video, we're gonna use two, alright? Okay, now we're gonna ask the user its age. The SC part here means we're going to use the first scanner we initialize. This part of the code inputs the user's age for confirmation. So now we're going to make the user confirm it if what he input was correct. Now, we're gonna use a second scanner, which is SC2. Of course, we can use SC here, but for clarity and simplicity, we're just gonna use SC2. Okay, now the first if statement, which means if the user inputs Y or confirms his age, this line of code we're gonna write is gonna be implemented. If not, then we can make the user input his age again. We can use a while loop here for the code to run back to the user's age scanner, but it's gonna be a lesson for another video. We're just gonna focus on the if else one. Now, we're gonna use another if inside our if statement. This is now then called as a nested loop, making our first if statement the outer loop and this one the inner one. Now, if the user inputs or confirms his age, we're gonna need to check if he really is eligible for a driver's license. Thus, if the user's age is greater than or equal to driver age, then the inner if statement is gonna come through and be implemented, which outputs that the user is indeed eligible. If not, then the inner else statement will be implemented. If the outer if statement is completed, there is no need for the outer else statement to run. In this case, there's no lines of code left to run, thus the program ends. Okay, now we're actually going to test the program. First, please input age. Okay, for the sake of the video, let's say I am 18. User's age is 18. Is this correct? No, because I'm actually 20. Okay. Please run the program and input your age again. So what actually happens is the program outputs please input your age, and then it asks for the user input, which ran our first scanner, which is SC. Yay! Now the program outputs our input, which is the user age, which is correct, 18, and it asks for our confirmation, which ran the second scanner, which is SC2. Then we meet the control structure, if else structure. Now, if the condition it wants is Y, so if we input Y instead of N, it would have ran this, it wouldn't be true, okay? Instead, if this condition is true, then it will run the if statement, right? But the condition was false, thus running else, which outputs please run the program again, right? So let's just say I am 17 years old. Let's say it's correct. Let's just say it. Okay, you are not eligible for driver's license. Why? Right? So you know what happens here. Program outputs, it asks for user input, and then it outputs our input, and then asks for confirmation, and then we meet the control structure. Here's the if else. If the condition is true, which is true because we input Y, then it ran the statement here, which is another if statement, which made this a nested loop, right? So now, if the user age is greater than or equal to driver age, it will output, okay, this is the condition, right? If this is the condition, right? So if the user age is, let's say, greater than or equal to driver age, then it would be true. But it is not, because we're only 17. So it would be false, thus running the else one, which outputs you are not eligible for a driver's license. Now, what happens if actually I'm 20, put my real age. Is this correct? Yes, it's correct. Oh, shit. Okay, let's just say I'm 20. User's age is correct. Yes, it's correct. And then you are eligible for a driver's license. What happens? Okay, first thing it's the dog's so noisy. Please bear with me. What happens is it outputs user input age, asks for user input, outputs our input, and then asks for confirmation, right? Now we meet the control structure again. Okay, so if this condition was true, which is it makes it true because we pressed Y or yes, then it ran this statement, another statement. If the condition here is true, which is user age is greater than or equal to driver age, which we made 20, we're 20, so it's greater than, so this made the condition true. Then it ran if, because the condition was true, right? Boom. Once it ran, you are eligible for a driver's license. Since there is no more code left, that's why the program ends. So hi, I'll be explaining the switch statement as simply and as fast as I can. So the switch statement is a type of selection control mechanism used to allow the value of a variable or expression to change the control of a program execution via multiple branch. So the condition is evaluated to get a value, and the value is matched to each of the case constants. So if no values match to any of the case constants, then it returns or runs the default one. So let me just show you how it works in code so you'll understand better. Okay, first we're gonna name our class switches because we're gonna be talking about this switch case statement. Okay, now we're gonna make the main method. And now we're gonna initialize our scanner because we're gonna need one to ask for our user input. Okay, we need to import the Java util first. Okay, now we're gonna ask the user to input his age and use the user age to contain his input. And now time for the control structure. In switch, we're just gonna make one case constant, and I'm gonna explain later why. In this case, we're gonna assign the value 18. Now, if the user age is equal to 18, we're gonna output you are eligible for a driver's license, right? Now, if the user's input isn't matched to the case constant, this line of code will run, which is, if it's not 18, then he isn't eligible for a driver's license. Yeah, this one's a default one. Okay, now we're just gonna add the break keyword. This will stop the execution of more code and case testing inside the switch block. Okay, now we're gonna test our program, right? Please input your age. Let's just say I'm age 20 because I really am. And then, oh, you are not eligible for a driver's license. So what really happens? So first things first, the program outputs please input your age, and then ask for user input, and then the switch case. What I input was 20, so it wasn't in the case constant, so it ran the default case, which outputs you are not eligible for driver's license. So let's try when I input 18. See, you are eligible for driver's license. I mentioned earlier that I'm just gonna make one case constant, because in switch case you cannot do greater than symbols. You can't just say user age is greater than or equal to 18 and then make the case switch run, because then it won't run, and it isn't possible unless we're gonna use the if-else control structure, right? Like the earlier examples, like in this case. Now, when are we supposed to use switch instead of the if-else ones? Well, you can use a switch when you are comparing multiple possible conditions of an expression and the expression itself is non-trivial, or you have multiple values that may require the same code, or even when you have some values that will require essentially all of another value's execution plus only a few statements. So in my experience, I haven't found case statements that work with greater than or equal to in a case constant. So that'll be it. Thank you, and see you in the next one.
Good day, this is Albert Layasan. In this report about statement level control structures, we will talk about sequences. The first sequence we will talk about is about goto statements. The goto statement is the most basic control structure. It specifies immediate transfer to a given statement. Its usual syntax is goto and label, where the label is either symbolic or numeric label of some statement. But the use of goto statements has downsides. There are two major objections to the use of goto. Number one, it allows spaghetti code. Spaghetti code is a pejorative phrase for unstructured and difficult to maintain source codes. Codes that overuses goto statements rather than structured programming constructs results in unmaintainable programs, which is unreadable, unreliable, and difficult to maintain if without restrictions. This is because of goto's capability of forcing any program statement to follow any other execution in sequence. We have a sample here. The first snippet shows x and it is assigned to the value of 3.0 and y assigned to the value of the quotient of z and x. And the second snippet shows the same values, but at the second line we have a label which is called here. The first obviously does not involve a divide by zero, but consider what you have to do to check the second that does not. The use of goto was challenged by Edsger Dijkstra in his famous letter to the editor. Goto statement considered harmful. CACM 1968. This launched the structured programming movement. Since then, subsequent languages downplayed or even eliminated the goto statement. An example is Java, as Java does not have a goto statement. The next sequence we will talk about is about exits. exit statement is an executable statement that immediately continues execution at the statement. Exits are also called user-located loop control mechanism. The exit statement can eliminate the need for repeated code when using only the sequence, selection, and loop control structures. This is convenient for programmers to choose a location for loop control other than the top and the bottom of the loop. We have snippet codes here. The one with the before has assigns the value of input to the read file, and inside the loop, the while loop, we also assigned again the value of input this is for the condition of the loop. But with the use of the after, we can just use the exit statement when the if condition is resulted to true. We can exit directly the loop. So in exit, in C languages, they specifically Java, C++, and C#, they use breaks instead of exit. We have sample code here. The following is an example of nested loops in C#. So this is our loop, the outer loop, and we have a nested for loops inside our outer loop. And at the end line, we have a break which directs us to which breaks the outer loop, the outermost loop. This is also called unconditional unlabeled exits. C and C++ use break. Java, Perl, and C# use unconditional labeled exits, which is break, and in Perl, last. In exit statements, we have a single level exit that always exit from the lexically innermost control structure, and we also have multi-level exit that may exit from a more distant lexically containing control structure. In some languages, the multi-level exit takes a numerical parameter, and in others, the multi-level exit takes a symbolic parameter. C languages, specifically C and C++, include an unlabeled control statement, continue. The continue statement transfers control to the control mechanism of the smallest enclosing loop. The continue statement is not an exit, but rather a way to skip the rest of the loop statements on the current iteration without terminating the loop structure. In our sample snippet here, we have a while loop that has get sum as its condition, and we get the value of the value. In our if, the condition, if we get a negative number, we will skip the addition of sum and value. This is useful when we want to avoid certain iterations in our loops. That's all.